is moving away from polar stuff, which not completely, but we're going to look at complex numbers and graphing them and then converting them to polar form. So let's see. Here we have 3 points, and first we're going to plot them. And graphing these isn't too bad. You treat it simply as an x and a y, because all of these are in the form x plus y times I. And so looking at this, it's negative 3 plus I. So we'll say that's, or not negative 3, but negative root 3. So that is negative square root of 3. If you check the calculator, you'll get about 1.7. So here's negative 1, here's negative 2. Negative root 3 is going to be about here. And then my y coordinate will be 1 because it's negative root 3 plus 1i. So there's my polar point. And then the only difference between plotting polar and rectangular is we will then connect that point back to the origin, the day line. So there is how we plot the point. So we plot the point, negative root 3, 1, and then we connect it back to the origin. And then converting it to polar form, take the state and give the polar form. Now we're going back to what we were doing at the very beginning of the review, and we essentially have the ordered pair negative root 3, 1, and we need to convert that into our theta. And then the polar form is actually going to be r times cosine theta plus I sine theta. So that's what we're going to do once we find the r and the theta. R is the easy one. R is the square root of x squared plus y squared, so negative root 3 squared plus y squared. That is the square root of root 3 plus 1. That'd be 3 plus 1, which is 4. And the square root of 4 is 2. So there's my r. And my theta, I like to use x equals r cosine theta. You could use y equals r sine if you want. You could also use the tangent one. But I know that x is negative root 3, r is 2 cosine theta. So I'm plugging it into this formula right here. And then we'll divide by 2. Negative root 3 over 2 equals cosine theta. And on the unit circle, you'll find 2 places where cosine equals negative root 3 over 2. One of them is, let's see, 150 degrees. And the other one is 210 degrees. And since this point is in the first quadrant, we're going to choose the angle in the first quadrant. We will not choose 210. So make sure you choose the angle that's in the correct quadrant. And then once you have r and theta, you simply take both of those things, r, theta, and you rewrite the polar number as r times the cosine of theta plus I times the sine of theta. There you go. 150 degrees. So there is the polar form. You find r and theta the same way we did way back at the beginning of the review, and then you throw it into this little formula for the polar formula complex number. Let's see, looking at number 31, let's give myself a little barrier so the problems don't start fighting. Okay, looking at 31, it's 3 root 3 and negative 3, so I'm going to plot that point. That is a positive x and a negative y. That's going to put me in the third quadrant. 3 times the square root of 3, what would that be? We could just punch that in the calculator and get a decimal approximation. And you get 3 times the square root of 3 to be about 5.2. So that's about 5.2 minus 3i. So I'll go out 1, 2, 3, 4, 5, and a little bit more. And then I need to go down 3. 1, 2, 3. And we'll plot that point. And then we will connect it back to the origin with the line. So there's the polar representation, or the representation of that complex number. And then we'll convert that into polar form. I'm going to have to copy 32 on the next page. Actually, let me get that right now. Alright, so, let's see, now I don't think that anymore. Okay, so now I need to get the complex number, or the polar form of this complex number. So that's 3 root 3 and negative 3 are the coordinates I just plotted. My r is going to be the square root of x squared, so 3 root 3 squared plus my y squared, which is negative 3 squared. We'll clean that up. Let's see, when you squared 3 root 3, let's see, 3 squared is 9. The square root of 3 squared is 3, plus negative 3 squared is 9. That's 27 plus 9 is 36. And the square root of 36 is 6. So there's my r. We'll put that on hold for a second. And then I know that x equals r cosine theta. So x, which is 3 squared root of 3, is equal to r, which is 6, because we just figured that out, times the cosine of theta. So now we're going to solve for theta right here. We'll divide both sides by 6. Divide by 6. On the right side, the 6 is canceled, leaving me with only cosine theta. On the left side, 3 over 6 reduces to 1 over 2. So now I've got square root of 3 over 2 is equal to the cosine of theta. Look at the unit circle. Cosine equals root 3 over 2 at 30 degrees. And again at this angle, which is 330. And you want to choose the one that's in the fourth quadrant. My point is in the fourth quadrant. So make sure you choose the point that is in the appropriate quadrant. That's going to be 330 degrees. We'll toss 30. And then the polar form is going to be r, which is 6 times the cosine of my angle, plus I times the sine of the angle. There we go. And one more, number 31. Let's see, we're going to plot the point first. It's negative 2 minus 2i, so that's going to be in the fourth quadrant. It's a negative x and a negative y. So I'll plot the point negative 2, negative 2, negative 1, negative 2, negative 1, negative 2. It'll be about right here. We'll connect it back to the origin. So there it is graphed. And then I've got to convert negative 2, negative 2 into an r theta. I know that r is equal to the square root of x squared plus y squared. That's the square root of 2 squared is 4, plus 4 is 8. And the square root of 8 does clean up to 2 square root of 2. So there's my r. Then get my angle to find theta. We'll do x equals r cosine theta. X is negative 2 equals r, which is 2 square root of 2 cosine theta. And then we will divide both sides by 2 root 2. Over here, the 2, everything cancels. Over here, negative 2 and 2 leaves with just a negative 1 on top. So negative 1 over 2 square root of 2. Nope. Negative 1 over just the square root of 2 is equal to cosine theta. And then if you rationalize that, multiply top and bottom by root 2, you will get the familiar looking negative 1 times square root of 2, or just negative root 2. Root 2 times root 2 is 2. And that happens at your 45-degree angles. Negative root 2 over 2 happens at 135. And again at 225. That's going to be on your unit circle. Choosing one in the third quadrant. That one out. And then I take my r, and I take my theta, and I roll it into my polar form of a complex number. Because I'm at 225 plus I sine 225. There we go. I think that's good for some. We just have one more section I'll do.